This video is about finding the limits of trigonometric function as x approaches. Limits of trigonometric functions. Limit of sine x as x approaches 0, so will be sine of 0. Sine of 0 is 0. Limit of cosine x as x approaches 0 is cosine 0, which is 1. Limit of tangent x as x approaches 0 equal to tangent of 0, which is 0. Limit of cosecant x as x approaches c is a cosecant of 0, which is undefined, so it's a dne. Limit of secant x as x approaches 0 is equal to secant 0, and this is 1. Limit of cotangent x as x approaches 0 is cotangent 0, which is dne. We have two special trigonometric limits. First one is the limit of sine theta over theta as theta approaches 0 is 1. So this formula works only if theta approaches 0 and the value inside the sine function matches the denominator. Say theta matches with theta. Second special limit, a limit of 1 minus cosine x over x as x approaches 0 is 0. And this formula works only if x approaches 0 and the value inside the cosine matches the denominator. Okay, so example 1. Let's find limit of sine x over 5x. So looks like we can factor 5 because inside the function sine we have x, so we need to have x, not 5x. So we can factor 5 as 1 over 5. So limit sine x approaches 0, sine x over x. Now this is by the special limit is 1. So the result is 1/5 times 1, which is 1/5. Find the limit of trigonometric function. The limit of sine x times 1 minus cosine x over x squared. So let's see if we do direct substitution. So you have sine 0, 1 minus cosine 0 over 0 squared. Sine 0 is 0. So 0, so this is 0. So this is also 0. So you get 0 over 0. So whenever you have 0 over 0, it's a indeterminate form. So that means we have to break it down into some useful functions. So we can apply those special limits. So we can try sine x over x and 1 minus cosine x over x. So by the product property, we can break it down into limits. Limit of sine x over x as x approaches 0 and the limit of 1 minus cosine x over x as x approaches 0. This is 1 and this is 0, so 1 times 0 is 0, so the answer is 0. Example 3, limit. Find the limit of trigonometric function. Sine limit x approaches 0, sine square x over x. So solution, limit of sine square x over x as x approaches 0 is equal to, so we do direct substitution. So sine square 0 over 0. Remember sine 0 is 0, so sine square 0 is also 0. So you have a 0 over 0. So again, indeterminate form. So we break it down sine square x into sine x times sine x. So you have a limit sine x times sine x over x as x approaches 0. Okay, so now we can break it down into two limits. You can try limits of sine x and limit of sine x over x here. In this, we can do direct substitution, sine 0. This is special limit, and so this is 1. So 0 times 1 is 0. So the answer in this case is 0. Okay, example 4. Find the limit of trigonometric function. Limit of tangent 3x over x as x approaches 0. So solution, limit tangent 3x over x as x approaches. So let's do direct substitution. So you always try to do direct substitution first. So if you do tangent 3 times 0. So tangent 3 times 0 like a tangent 0, and tangent 0 is 0. And this is, so 0 over 0. Indeterminate form. So therefore we can breaking down. The only thing we can do here is we can rewrite tangent 3x as sine 3x over cosine 3x. Okay, so looks like sine 3x we can attach with x, and this we can separate like this. So limit x approaches 0, 1 over cosine 3x times sine 3x over x. Now by this again, the limit of product is the product of the limits, so we can rewrite this as limit of 1 over cosine 3x as x approaches 0, and limit of x approaches 0 sine 3x over x. Okay, this one we can find by direct substitution, but this one looks like inside sine you have a 3x, on the denominator you have x, so you can make it 3x. So what we can do, we can multiply 3 here and multiply 3 here. Okay. Okay, so now we have direct substitution, 1 over cosine of 3 times 0, and we multiply 3 outside, 3 here. So now we have a 3 times limit of sine 3x over 3x as x approaches 0. So let's change the variables. So let's set y equal to 3x and change x equal to 0. Remember, if I put 0 here, so it becomes y equal to 0. So we change x goes to 0 to y goes to 0. So we rewrite 1 over cosine 0, 3 times limit y to 0, and this becomes sine y, and 3x becomes y. And now by special limit, this is 1, and cosine 0 is 1, so you have 1 over 1 times 3 times 1. So the final answer is 3.